Resin transfer molding, or RTM, as it is commonly referred to, is a closed mold process in which reinforcement material is placed between two matching mold surfaces, one being male and one being female. The matching mold set is then closed and clamped, and a low viscosity thermoset resin is injected under moderate pressures into the mold cavity through a port or a series of ports within the mold. The resin is injected to fill all voids within the mold set and thus penetrates and wets out all surfaces of the reinforcing materials. The reinforcements may include a variety of fiber types in various forms, such as continuous fibers, matte or woven type construction, as well as a hybrid of more than one fiber type. Vacuum is sometimes used to enhance the resin flow and reduce the void formation. The part is typically cured with heat. The vacuum infusion process, sometimes referred to as VIP, is a technique that uses vacuum pressure to drive resin into a laminate. Materials are laid dry into the mold and the vacuum is applied before resin is introduced. Once a complete vacuum is achieved, resin is literally sucked into the laminate via carefully placed tubing. This process is aided by an assortment of supplies and materials. Vacuum infusion provides a number of improvements over traditionally vacuum-bagged parts. These benefits include better fiber-to-resin ratio, less wasted resin, very consistent resin usage, unlimited setup time, and it is cleaner. The following are some key terms and practices to remember when working with composite materials. The basic two-part mix for epoxy matrix material is resin and hardener. One of the best ways of being sure that the matrix resin for a composite repair has been properly mixed is to mix enough resin of each batch to make the identical layup. Pot life is the length of time a catalyzed resin will remain in a workable state. Molds hold the surface in place while materials cure and harden. They are called male and female. When replacing honeycomb core material, the ribbon direction of the insert must be the same as the ribbon direction of the original core. You can use a ring coin tap test on composite structures. A change in the sound made by the coin being tapped on a piece of composite structure may be caused by damage or by transition to a different type of internal structure. The strength and stiffness of a properly constructed composite buildup depends primarily on the orientation of the plies to the load direction. Water is the only fluid normally approved for use in machining composite materials. Any other fluid would contaminate the material and prevent subsequent bonding. Hole-filling fasteners such as conventional rivets should not be used in composite structures because of the probability of causing delamination. When a conventional rivet is driven, its shank expands to completely fill the hole. The force applied by the expanded shank will cause the material to delaminate around the edges of the hole. When repairing damaged fastener holes to composite panels, chopped fibers or flux cane can be added to the wet resin to strengthen the repair. Microballoons do not add any strength. Superficial scars, scratches, surface abrasions, or rain erosion can generally be repaired by applying one or more coats of suitable resin, catalyzed to cure at room temperature, to the abraded surface. The preferred way of making a permanent repair to composite structure is to remove damaged area and lay in new repair plies, observing the choices of materials, the overlap dimensions, ply orientation, and curing procedures. The following pictures are examples of composites used in the aerospace and aviation industry. The Boeing 777 makes extensive use of lightweight, cost-effective structural materials that lessen the overall weight of the airplane and contribute to the fuel efficiency. Composites, including resins and adhesives, account for 9% of the 777 structure weight. The B-2 stealth bomber combines revolutionary aerospace technologies in unprecedented design, development and manufacturing systems and processes in the world's most advanced aircraft. Stealth and performance requirements make it necessary to build the B-2 with an unprecedented amount of composite materials. The Pegasus X-47 marks an innovation in UAV technology, a remotely operated stealthy aircraft that relies on its small size, infinitesimal radar cross-section, and non-pilot limited maneuverability to approach, identify, and attack enemy air defenses with precision munitions. The all-composite airframe was powered by a single Pratt & Whitney turbofan. Scale Composites' program of suborbital human spaceflight uses the reusable spacecraft Spaceship One and its launcher White Knight. The main structure is of graphite epoxy composite material. The F-22 construction is 39% titanium, 24% composite, 16% aluminum, and 1% thermoplastic by weight. Titanium is used for its high strength-to-weight ratio in critical stress areas, including some of the bulkheads, and also for the heat-resistant qualities in the hot sections of the aircraft. Carbon fiber composites have been used for the fuselage frame, the doors, immediate spars on the wings, and for the honeycomb sandwich construction skin panels.